You skipped some words. Moving up. Yes. What does that tell you about the acceleration? Correct. Got to find those context clues in the problem. Not only that, but then that would become like that. There you go.
Alright, so the acceleration is 0.
I see that.
Well, yeah, that's kind of
Very dumb. Alright, so
to get to the bottom.
we have the velocity, the acceleration.
The gravity force of gravity would be -835.3, so it's -835. Do we need a decimal? A decimal?
If it's multiplying, then it's going to be the least amount of 6 things.
There's only 3 6 things, so it's -835.
Okay, so then normal force is going to be the opposite of 835. And it's not moving to the right or left or anything like that.
No, it's not.
Alright, let's face off, everybody. Let's face off. Let's see what you got. Let's see who's all for what. And remember, the purpose of the face-off is not to do a presentation of your board. It's for everyone to look around and compare what they have to what everybody else's board looks like. If you see something different or that you don't understand, ask questions until you do understand or make corrections.
Why do you only have 3 digits for your forces?
Because she said there's 366, right? 9.1. Yeah.
9.1.
It's a constant.
Well, we got it.
What is it?
Which area? Where?
They both have arrows. What does that represent?
I was just saying the velocity direction.
Direction.
We were just trying to find something fun.
That's the whole point of a problem's problem. Just tell us what you can find.
And then acceleration has no direction because there's no
You can do a motion
You could do a motion map.
because we have velocity, we have time.
But he's got a PBT, a VBT, and it looks like he may have been starting an ABT. It would just been 0.
We could have done how far it went. We could have.
You guys realize that on the elevator video, you remember the elevator video? If we timed it,
We can tell how.
you could tell how tall the elevator, or how far the elevator went, up or down. Yeah.
And the height of the building.
Yeah, if it went from bottom to top, you could tell the height of the building. Just like
Not
now.
necessarily consider the height of the elevator.
No.
Bottom of the elevator.
Well, yeah, you're right. From the bottom to the bottom, you would know how far the elevator floor moved.
Yeah.
Itself.
There could be stuff built on top.
Correct.
Yeah.
Correct. And the elevator doesn't necessarily go to the roof. Okay.
We should have.
Are there any questions, or I should say, what are the questions? What was the hardest part that confused most people at the beginning?
The acceleration.
The acceleration.
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 And it was exactly what Jada and other people said. Didn't read the stupid problem.
We did.
Yes.
We got started thinking about it.
Exactly. That's the
We just
key.
read it and
We
just,
read
like,
constant
skimmed it.
velocity
You
and then we were
didn't
like,
realize that there were clues there. Remember, this is not math class. It's not just take the numbers and do things with the numbers. There will be hidden information in the problem, context clues and things like that. In fact, if this was an assessment and it was asking about forces, the time would be irrelevant. But because this is a problemless problem and it's just about whatever, the time did have some value. Just like on
And the actual velocity.
on the last assessment, we had the skier, and I gave you the time. And I had numerous people who asked, what am I supposed to do with this time? Is it important? And all I could say was, that's up to you. But it really didn't matter. It did matter for the second problem, though, because it asked you how far the person went.
And the actual numbers of velocity.
Correct. the value, it didn't matter. All that mattered was that it was constant. All right, let's clean our boards. We'll mind our P's and Q's. All right, y'all listen up while we clean our boards. Who wants to read it today?
Me.
All right, Migdalia, will you read our objectives, please? Read them loud so everyone can hear while they're cleaning.
I can determine the net force acting on an object based on the forces observed acting on an object. Number 2, I can draw 3 body diagrams based on the forces observed acting on an object. Number 3, I can sum forces acting on an object in the x or y axis. Number 4, I can label the forces acting on an object in the system. Number 5, I can determine the mass of an object based on the force of gravity acting on the object or the force of gravity acting on an object based on the mass of the object.
Yeah, it's a long one, yeah.
Number 6, I can predict the motion of an object given the forces acting upon it in a system using graphical analysis or a mathematical model. Number 7, I can determine the magnitude and direction of individual forces acting upon an object in a system based on measurements of its motion using graphical analysis or a mathematical model.
Thank you,
That
Migdalia.
was a really, really long one.
All right, so the two new ones are 6 and 7. Predicting the motion. So now that we have a way to relate forces to acceleration, you can connect forces to motion. And so, just like we said a few seconds ago, if you know the acceleration of the elevator, which you can tell from what the bathroom scale reads, and you timed it, you can tell us how far it went. If you put an accelerometer, and all your phones have accelerometers, you can take an accelerometer and put it in your car and time it, and you can tell how far you drove. In fact, so now, the elevator accelerates upwards at 2.00 meters per second squared, and I am not making it a problemless problem. I want a quantitative free body diagram, and I want you to sum the vertical forces. When I say equation, I want you to do the sigma thing. All right, I'm going to put 5 minutes on the clock. You guys should all be able to do this in 5 minutes. And then we will face off. So right here, this is not going to equal 0. It's going to equal mass of the system times acceleration of the system.
He really is.
So like right here, there should be a space. Like it should say sigma Fy, sum of the forces in the vertical direction, because these have to be turned into equals the mass of the system times the acceleration of the system equals, and then you know there are 2 forces happening, force of gravity and the normal force. Now which of these do you know?
Wait, no, we have to change program.
You know the force of gravity. You know the force of gravity. What else do you know? You know the acceleration. And what else do you know? The mass. So you know both of those. If you know both of those, then you can solve for that.
But we know the 170, and that doesn't make sense.
You said that's the force of what? No, because your acceleration shows what? No, acceleration is showing your imbalance of forces, right? Because that's not a constant velocity. When you add it to that, you would add this to that. What? No, if it's an imbalance, it means it's your sum of forces, right? When your sum of forces equal. So this is not your force normal force. This is your sum of forces.
Oh, okay.
Okay. And what is your sum of force equal?
If this is 107 and this is 835, which way should the person be accelerating? Which way are they accelerating? So this is not a reasonable answer. This is net force. This is not normal force. F net equals force of gravity plus normal force. This number, remember, is F net. Well, if you did that, that would still not be right. Redo this, like put F net as the 170, put this as an unknown, and solve the equation like that. And don't forget this is negative. There you go.
Should we do this equation? Because that's what she saw there, or should we do something else?
Well, you rearrange the equation, so sigma Fy is F.
I'll stop subject about this.
All right, when Super Mario Brothers is over, we'll face off.
170 minus
subtract a negative, what does it become?
Pardon the interruption, teachers assistant also from the sicknesses and forces of burnout.
If you subtract a negative, what does that become? You're multiplying? Alright, let's face it off, people. Bring it in.
You're adding in one place, but the percentage of your hospital is 170, it only goes to one spot. No,
I'm
ready. So we add them together, you get 170.
You ready, Jared? Alright. So what do y'all think? Does everybody agree on everything?
No.
No?
They're not forcing or wait around.
I got too many,
So that's something we should figure out. How many, let's start at the top. How many sig figs should we have for force of gravity?
Force of gravity, I have 5.
Anybody besides 5? Okay, 5 gets it. Alright, what else did we calculate?
The net force.
Net force, how many should we have for net force?
3.
You guys have
100, the 170.
Yes, and you put the little dot. You see how they put the little dot?
Oh,
You gotta put the little decimal, otherwise that 0 is not significant. Oh, is that, okay. So got a little, there's a little smudge on there.
They
Okay.
probably got erased on accident.
So then the next question becomes,
Your normal force.
yeah, how many sig figs in your normal force?
It
Because
has
it's
4.
adding or subtracting.
When you add or subtract, you start right
Goes to
here.
the one place.
This one only goes to the one
Goes to the ones place.
This one can only go to one place, you keep it at the one.
You have two. You have
So this right here is 0.
Exactly.
Yeah. Whatever comes after the decimal is irrelevant, because it only goes to one spot.
I have problems with this.
Everybody. But yes, and so actually, a better way of saying how many sig figs should the normal force have is not how many, but to what place. Because it ends up with 4, but it's to the ones place. Very good. You guys ready for more?
Yeah. Always.
You guys should be getting quicker. Yes? Okay. All right.
Should be.
Let's find out.
Should be. That is
Yeah.
So the elevator gets to the top of the building and begins going down, accelerating at 3 meters per second squared.
His mass doesn't change, but his acceleration does, so. What's his?
Not here. Here, what's wrong with this?
Times.
Yes. Where are we going? Very good.
Not at the point, so it's 255. No.
All right, are you guys ready?
Yes.
All right, let's face it off. My people doing motion, don't worry about it. Don't worry about it. It would have been 1/2 AT squared.
That's what we.
Yes.
I said it.
It would have been 1. Yes, please. Sorry.
I said it. I did.
Yes, my motion people, it would have been 1/2 AT squared. So let's see, 25 times 3, 75, half of that is whatever it is.
Yeah.
That's how far it went.
Okay, that's an awesome math.
147.5.
There you go. Okay, let's look. Does everybody agree on everything?
See your hard work.
Then do we agree on sig figs this time?
Ignoring my
580. 580.
Ignore menacing decimal.
Yeah, I assume everybody wants to have a decimal behind the 0, because it does make a difference. We'll have the same process. Very good. Is this getting easier?
Yes.
Are there any questions or things that you guys are still stumbling on?
I just need on remembering the signal.
Okay, well, we're just going to keep using it over and over again, so that'll help.
Okay. Are you having
Are you
another
gonna
study
flip
day
it on
that
us to give us most of this?
Yeah, I figured it does it every time.
At some point.
Does it every time.
All right, you guys ready?
For what?
For the next one. We're not done with this elevator yet.
That's
Next